So here we see an example of a tan graph. And we also could see that as far as the curve, it is periodic, but it doesn't seem to be continuous. We see that we have asymptotes at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. We see that we have some theta intercepts here at negative pi. We see we have again one at 0. We see it's also at pi, and it looks like it's at 2 pi as well. We see that y equals 1, roughly around here. So exactly halfway between 0 and pi over 2, we know that tan is going to be 1 when we have a theta of pi over 4. And we also have one at 5 pi over 4. And we can see we have another one exactly a pi to the left there at negative 3/4 pi. Continuing, we see that y equals negative 1, roughly at these marks. And those will be halfway along between pi over 2 and pi, which is at 3/4 pi. We see that our next one is between negative pi over 2 and 0, which is at negative 1/4 pi. And we also see that if we go another pi to the left, we end up at negative 5/4 pi. All of this means that we have a period of pi. These same numbers seem to occur every pi. We also see that if we look at the domain, that we are still allowed to have our value of theta. But in this case, it's going to be all thetas that are real with some exceptions. So in this case, theta cannot be pi over 2. And we know the period here is pi. And when we talk about n, we're talking about any number in the integers. And we're talking about theta being in the reals. So that we have all reals for theta with those exceptions. Because we see some asymptotic behavior, we know that as far as range goes, there's nothing that's out of limits here. So we'll have all values of y such that y is a real number. So here we have one of our word problems having to do with tan. And the A part says we need to determine the relationship between horizontal distance from observer to the plane and the angle in degrees formed from vertical to the plane. So let's draw quickly a quick sketch. We have our observer. We have the direct vertical being above us. And we have a plane some distance away coming towards us. Now we have that distance here. We know that vertically we're looking at a distance of 6,000 meters. We're looking at a theta here between the vertical and the plane. And let's represent our unknown horizontal distance by d. So in this case, we know that the tan of theta is going to be d over 6,000 meters. If we rearrange, we end up with this relationship. We have 6,000 times the tan of theta. So we have our a value, if you will, 6,000. We're going to be vertically expanding our tan function by 6,000. So the most interesting part of this graph will lie between our negative 90 degrees and our 90 degrees. That gives us exactly negative pi over 2 radians and pi over 2 radians. We have enough to work with at least one cycle of tangent here. We know that at the 0 point we'll have 0, 0. We know that we have asymptotes, drawn with my best broken line, at 90 and negative 90. We can see that exactly halfway along, we would have our 45 degrees. And at 45 degrees, tangent is 1. We're going to multiply that by 6,000 though, so we know it's going to go up to 6,000. So if we label our y-axis as 2,000, 4,000, 6,000, 8,000, and 10,000, you can see the behavior between 0 and 90 degrees. We see that we're going to end up crossing at 45 degrees, we'll cross 6,000 meters. So ours will slope up towards that point, and there it's going to simply take off. It's going to get closer and closer and closer to 90 degrees, never quite reach it, and it's going to get higher and higher and higher. Going the other way, we'll have exactly halfway along, being at negative 6,000 degrees, sorry, negative 6,000 meters. And so we see it goes all the way down to here. And it does change the inflection point somewhat. And we have different concavities happening as we go along. It almost goes smoothly through the 0 and then changes to go asymptotically towards 90. That's going to curve towards negative 90 as well. Now you might ask, why did we go from negative 90 to 90? Well, in this case, a 90-degree angle means the plane is directly to our right along the ground. And then, of course, negative 90 means it's going to be on the ground to our left. Neither of which is possible if it's going at a constant height of 6,000 meters. And explain what happens when the angle is equal to 0, that means we're looking at directly above us, at which point the horizontal distance would be 0. So yes, we can even model some real-world situations using tan. To continue, you need to go to page 262, numbers 2 to 4, and 8 to 10, and I wish you luck.